So this is on page 224. So if we rewrite this with the plus 2 on the other side, and the reason when I rewrote it, I didn't decide to write what was inside right away, because I wanted to do something all at once. But we have to notice here, what's this 3 and this 3 going to do? This first 3 is a horizontal stretch, compression, translation, compression. Because you would multiply the x by 1/3. And this 3 is going to be a horizontal translation. But we had our special note. You have to factor the 3 out. So before we can go from left to right, it's nice to write the plus 2 on the other side, but we're also going to factor out the x plus 1. So now we can make a list, a shorthand list of what everything's going to do. That negative, is it going to affect the x or the y? It's the y. Y is going to get multiplied by a -1. That's going to flip it over the x-axis. The 3 is going to affect our x because it's inside the square root, and our x is going to get multiplied by 1/3. Our 1 is going to move everything 1 to the left. And finally, we're going to move things up 2. Now, this is a type of question that typically the original graph, wouldn't be given to you, because this is one of your parent graphs that you know and should be able to draw quickly. Now, as far as going through these transformations, whenever you have a square root graph, this point, 0, 0, is the most important, because that's our starting point. But then which other points that you choose to use to see where it's going to end up is dependent on you. Now, one of the things that I always do when choosing my points is I look at my list of things that are going to happen. And especially if there's any fractions, I think, okay, maybe I'm going to try and choose a point so that my fractions work out to nice numbers. I'm going to choose a point which we're going to get fractions, just to show you how that works. So if you choose a point that ends up with fractions, it's not wrong, and you can still work with it, but then you're working with fractions. But we're also going to try and choose a point that works out nicely. So the next point on your square root graph that you know is 1, 1. So I'm going to do that one just because it's the next point. And sometimes you do that. You just go through the first 3 points and start, and then you'll find out what happens to those points. But since I have a fraction thing here with the x by 1/3, what is the first nice point on the square root graph that if we multiply the x coordinate by 1/3, we'll still have a whole number? 9, 3. So if I was doing this myself, I'd probably only do 0, 0, and 9, 3 and go from there. But right now, I also want to show you what happens if you choose a point that ends up with fractions. And it's not bad, but what does it look like when that happens? Sometimes you might have something that there is no choice. You're going to end up with a fraction. We deal with all of our stretches and compressions first. So if I'm going to describe them, here I'm going to write, we're going to multiply y by -1 and x by 1/3. We're going to get our new points as a result. And then we'll do all of our translations. So 2 to the left, or 1 to the left, and 2 up. So 0, 0, when multiplying by things, will stay 0, 0. Our second point, when you multiply by 1/3, you're going to get 1/3, and y by -1 will be -1. And here, x by 1/3 will be 3, -3. So we see in that second point that we have a fraction already. Moving things left 1 up 2, well, it's when we get to this one that it gets a little bit tricky because we just have to remember how we add and subtract fractions. You've got 1/3, and if you want to subtract 1, how do you do that? Good question. So here for the y coordinate, you're multiplying by 1/3 and the negative. So you see how easy it is to make those little mistakes and mental. So yes, it is supposed to be a -3, but yeah, I saw what you did there with the 1/3. So if we have 1/3 and we're subtracting 1, how do you subtract with fractions? You have to make the 1 into a 3/3, get a common denominator, and then you're going to end up with -2/3. -1 up 2 will get you to +1. And this point, which has nice numbers, left 1 will get you to 2, up 2 will get you to -1. So now when we go to draw our final graph, well, you can draw it on the graph. Do you want to draw it on the same graph? Because it's already there? Okay. Sometimes drawing it on the same graph causes some confusion just because it gets messy. If this was a question that they didn't give you the graph, then I would suggest you draw your parent graph on one and draw your next one on a separate one. But since the graph's there, we can do both. So if I was drawing on the graph that we have, -1, 2 is right there. Okay. Oh, it goes by 2's. Man, always gets me. So this is -1, 2. And 2, -1 would be there. And -2/3, 1. Okay, so here you would have to say, well, if this is 1 here, -2/3 is a part of the way there. And you just sort of estimate where -2/3 is. But it's not the easiest thing to do. Okay? Now we've got 3 points. You know that 0, 0 was our starting point. So we know that that's our starting point. Now something's going to happen here. Don't graph this yet. I'm going to graph it with a pen that's going to erase on us. This, when I join these, you might be tempted to go like this. You might be tempted to go like this. So we have to know what is the general shape of the graph, because we have to have the shape of our graph correct. In order to do that, that's where we go back and think, well, what do each of these things do? Y by -1 would flip it down. X by 1/3 would squish it this way. Then it gets moved up 1, or sorry, left 1, up 2. So it makes sense that that's the shape of our graph. Especially the reflections is what you're going to have to look at for figuring out the shape. So now that we've thought about each of those things, we know that the shape of our graph needs to look like that. It just asks for the domain and range of our new graph. So now for our domain, what is the smallest x value? Smallest x value is -1. X has to be bigger than or equal to -1. There is no smallest y value, but there is a biggest y value. The biggest y value is 2. So all the y values are less than or equal to 2. Okay, try 8 and 10 right now.